Hi, welcome to Wise Guys. This video I'm going to show you is simplifying radicals with variables. The first question is square root 16 a squared b times c to the 4 exponent. We can follow the rule. We can separate each factor because 16 multiply a squared multiply b multiply c 4 exponent. We can separate each factor. So 16 square root 16 square root a squared times square root b times square root c to the 4 exponent. Square root 14, we know is 4 because 4 square root. And the a square simplify with square root, we get a. The b only one exponent, so that's why only stay inside. And the c is 4 exponent, we can get out the radical becomes 2 c squared, right? C squared. That's the answer equals 4ac squared times square root b. So as the same when we simplify square root, it's always matching if it is square or if it's multiple of square. So this one is square. So we simplify with the radical index 2, you got a. This is c to the 4 exponent, which is multiple of 2, right? And you can see as long as the exponent inside the radical is multiple of the radical index, it's divisible, or we can say it always can simplify it. Second question, have square root 64 times c to the cube and multiply a squared plus b squared. The difference of the second question with the first question is we have a squared plus b squared. So that's why we need to be careful this one, because a squared is one term, b squared another term. You have two terms. The 64c cubed is a common factor with a squared and b squared. That's why they pull out. So now we still follow, we can separate the factors. So that's why 64 is coefficient. We can separate 64, multiply, this is all multiply. Square root c to the 3 exponent, and square root, this one is a squared plus b squared. We need keep inside the bracket, treat as one group. A squared plus b squared cannot be separated into square root a squared plus square root b squared. No, you cannot do this way, right? So I just say this is very be careful, this one. So a squared plus b squared cannot not equals to a plus b. No, not equal. You cannot, even you can not write it this way. Yeah. If you can write it this way, you can equals a plus b, but this is not, because plus is two terms, okay? That's why this situation, what we need to do is this one has to be equals to square root 64 is 8. This one we can write c squared times c, right? We're always matching exponent with radical index. This is the square root, we write c squared. And this one stays same. So the answer is a times c, and this c stay, so with that one, so you can write one more step. And the answer is 8c times square root c times a squared per b squared. Okay, this is second question. The third question is show you the cube root. So cube root 27 times x to the 4 exponent and y to the negative 12 exponent and times z. So because all this is multiply, right? So we can separate into 1, 2, 3, 4. Cube root 27 and multiply cube root x to the 4 exponent times cube root to the y negative 12 exponent times cube root z. So then we can do, because 27 is, you can write into 3 cubed, right? 3 cubed. And x4 exponent, you can separate x3 exponent times x, matching with radical index. And this one you also can write this way, because 12 is 4 times 3, which is multiple of 3. So that's why you write y negative exponent, you just do cubed, this is cubed, this is cubed, 3 multiply which number? Equal negative 12 multiply 4, right? That's how you can simplify this way. And this is z only one exponent stay inside. So the answer would be, this is 3, and this one is x. The cube root x stay, and this one cancel with this one is y to the negative 4 exponent, and this will stay that. So the answer will be equals, you write 3x on denominator, the y negative 4 exponent we need write move to the bottom, because the answer we should be only with positive exponent. If you have negative exponent, you need to write positive exponent, which move negative 4, y negative 4 to the bottom, denominator as y to the 4 exponent. And this one with this one, you can combine together, which is cube root x times z. This is the answer, right? Cube root. Question 3. And we have question 4. Question 4 I'd like to show you is with a fraction. So 5 roots inside the radical is negative 32 x to the 7 exponent, and on the denominator is y to the 4 exponent. So because 32 is multiply x to the 7 and divide the y 4, all this is one term. First of all, we move negative in front because this is odd number, radical index, so the negative move in outside. 5 exponent. This one I'm not going to separate it because the bottom one, if you separate, you write more steps. So let's try not separate. So 32, you can see what the 32 related to 5 radical index. You can write which number to the 5th exponent, or is something you can think about. You can factor out 32, divide the 2, then eventually you find 32 actually is 16 multiply 2, which is 2 to the 4 exponent, multiply 2, which is 2 to the 5 exponent, right? 32 actually 2 to the 5th exponent. Then this is x to the 5 times x to the square, because this 2 multiplied together equals x to the 7 exponent. So the bottom is y to the 4 we need to rationalize the y to the 4 exponent, get rid of radical, but the 4 exponent we need to make 5 exponent by multiply y to the bottom and also multiply y to the top. This is always you need. If you multiply y to the bottom, you need to multiply y to the top as well. The value doesn't change, right? So now, after this one, you can see we can write into negative the 2 to the 5th exponent after radical index 5. We have 2, exactly get 2. This is x5, you got the x. These two stay inside the radical, still have 5 roots x squared y. And this y, 4 exponent multiply this y become y to the 5 exponent, and get out radical becomes y, right? So this is the answer. The last question I want you to use is square root 4 minus 9 to the y squared. I put this question because it's not few students. Sometimes they feel like, oh, 4 equals, got radical, square root is 2, minus square root 9 is 3, square root of y squared is y. No, this is wrong. So the reason is 2 terms. You cannot do this way because each one you cannot write square root of 4 minus square root of 9 over 12. This one is not equal. This one is not equals square root of 4 minus square root 9 over y squared. Not equal. The reason is this is a minus, so we need to keep together. So how to solve this question? To solve this question, we need to get common denominator. So the inside the radical, we got the common denominator is y squared. And the 4 become 4y squared, right? Because the 4 is over 1. The 1 and the y squared, the common denominator is y squared. So, and you can double check 4y squared divided by y squared, you got the 4. That's why the common denominator, you multiply 1 with y squared, multiply 4 with y squared. So minus 9, because this is the denominator of y, so we don't need to do any change. Once to this one, you can see then the top is together one term. You can do this way. Now you can separate. The top is 4y squared minus 9 together. The bottom is square root of y squared. So this one you can get out radical y, and this one stay inside 4y squared minus 9, because 4y squared minus 9 you can factor out in 2y plus 3 multiply 2y minus 3, but you cannot make perfect square. If you can some expression, maybe another question, you can make a perfect square and the whole group can get out the radical, but this question can't. So this is presented by wise guys. Done. Thank you.